Hey kids,
Oh my God.
welcome back. Let's take a look at these expressions. X squared over x to the fifth. Now, using the quotient rule for exponents, you take the top exponent minus the bottom one. You end up with x raised to the negative third power. Let's do this a different way.
And this is why I only record my hand. If you expand this, just like we had done in the last video. Also, it's funny when I do my normal voice.
If this is even my normal voice.
Maybe do like my movie voiceover voice. They're always like,
Please stop.
so now let's simplify these. When I simplify these, coming soon. These guys reduce, those guys reduce. What do you have left in the numerator?
3.
I got 3 in the numerator. Are you even kidding me?
0.
Is uno y uno.
In the numerator.
You multiply those to get what in the world are you got? 0. You kidding me? That's a 1. But you have all your x's in the denominator. You've got 3 factors of x. Do y'all agree? Now, since we started with the same expression, that means the end results must be the same as long as we've done everything legitimately, right? I didn't screw anything up. I used the quotient rule, and then I just simplified with fractions. So it tells me these guys have to be the same. So what that tells me is I've got this negative exponent right here, and I can rewrite this to be a positive exponent just by putting it in the denominator. So these are the properties that we're going to be working with. When I have x to a negative exponent, I can put it on the other side of the fraction so it can look like this. Or if it starts as a negative exponent in the denominator, you can move it to the top to be x to the a over 1, which would just be x to the a. So what we're going to do is we're going to work through a few examples.
Wait. How can I go from being x to negative a and then you put it to the denominator?
It depends on where your negative exponent starts. Okay. So, for example, let's do this. If I give you x to the 5th over x to the 15th, or x to the 12th, excuse me. Now when I look at this, my mind thinks about what it means. What does x to the 5th mean? X to the 5th means I have how many factors of x in the top? 5. How many factors of x on the bottom? 12. When these guys start canceling, I'm going to run out of x's where? In the top. Where will the rest of your x's be?
On the bottom.
How many will you have in the denominator?
7.
What's going to be in my numerator?
1.
1. Now,
4.
hold on. If you had done the quotient rule would say you take the top exponent of 5 minus the exponent in the denominator, and what does that give you? X to the what?
Negative 7.
But as I said, that's the same thing as what we have up here, right? It's the same thing. Now, you are not allowed to leave negative exponents for your answers for these problems dealing with exponents and polynomials. You're not allowed. There's only one place where negative exponents are acceptable, and that's when we're talking about scientific notation, but we're not there right now.
So always put it back into either factor form or not negative.
you have to make sure that your answer does not have a negative exponent. Negative numbers are okay. Negative exponents are not. Now let me show you how things can be really easy if you will let them be easy. X to the 10th, y to the 12th, over x to the 7th, y to the 20th. Now when I look at this, when I look at this, I'm trying to figure out where do I have more of my variables? Where do I have more x's in the top or bottom? Where do I have more factors of x, the top or the bottom?
Top.
I have more x's in the top. How many more factors of x do I have in the top?
3.
So I'm going to write this as x to the 3rd. Where do you have more factors of y?
5.
How many more do you have in the bottom?
8.
So there you go. X to the 3rd over y to the 8th. Is that okay? Now let me show you the other way of working this guy. If I did the quotient rule, it would say take the top exponent, 10, minus the exponent in the denominator, which is 7. For the y's, you have 12 in the top minus 20 in the bottom. Okay. When I do this work, I end up with x to the 3rd and y to the what? This answer is not acceptable because of the negative exponent. Now, is x to the 3rd okay? X to the 3rd is okay, but it's that y to the 8th that's not. So you keep the x to the 3rd in the understood numerator that we already have it in, because that's understood to be over 1, and you move this guy to the other side of the fraction bar, so it's y to the 8th in the denominator. You get the exact same answer, just a different way of looking at it. Now, I prefer just to look at it and say, where do I have more x's? Where do I have more y's? So I think it's a lot easier, and I don't really have to deal with my signs. I just have to worry about can I subtract. Any questions about this guy?